In a three-phase balanced system, an ABC sequenced Y-connected source with VAN equal to 220 at 0 degrees volts RMS supplies power to a Y-connected load that consumes 36 kilowatts of power in each phase at a power factor of 0.75 lagging. Three capacitors, each with an impedance of minus J 2.0 ohms, are connected in parallel with the original load in a Y configuration. Our task here is to determine the power factor of the combined load as seen by the source. The original situation, prior to adding the capacitors, the real power consumed, P, is equal to 36 kilowatts. This, along with the power factor, can be used to give us the power factor angle. PF, which is the power factor angle theta, is equal to the inverse of the cosine of the power factor, which equals the inverse cosine of 0.75, and that is equal to 41.41 degrees, lagging for each phase, which means the apparent power VI conjugate coincides along this line. We know that Q is equal to P tangent theta, which is equal to 36, the tangent of 41.41 degrees, which is equal to 31.75 kVAR. Therefore, S is equal to 36 plus J 31.749, or in a polar coordinate formation is 48 at 41.4 degrees. And this is the apparent power for each phase. If we now add the capacitors, the real power is unaffected by this, and thus the new power is equal to the old power, which is equal to 36 kilowatts. However, the Q new, the new reactive power, is equal to the old reactive power plus QC, where QC is the reactive power supplied by the capacitors. This is an equation that states reactive power is equal to the magnitude of the voltage dropped across the squared divided by the current conjugate through it, and in this case QC equals the magnitude of the voltage squared divided by XC conjugate, and this is the reactive phasor of the capacitor. We haven't given the fact that the capacitor impedance is minus J 2.0 ohms, and because it is pure reactance, we can say that XC is equal to minus J 2.0, and that XC conjugate is equal to plus J20. We can replace XC conjugate in our equation for QC, giving us minus J220 squared divided by 2. You will notice that the J in the denominator becomes minus J in the numerator. The reason for that has been explained in previous problems, as you can see here, which subsequently will equal minus 24.2 kVAR leading. Therefore, Q new is equal to 31.79 minus 24.2 equals 7.59 kVAR, which gives us our new apparent power. Let's move our calculations around in order to make some room to continue. We now have the information to calculate the new apparent power using the Pythagorean theorem and the known values, which, after squaring them and finding the square root, we get 36.6 kVA. The power factor angle can be found by using the inverse tangent using the same values, which is 11.9 degrees, and the new power factor may be found using the cosine of 11.9 degrees, which gives us 0.98 lagging. Are you looking for a way to keep your home powered and your family safe during any weather conditions? Announcing the launch of Bluetti's most powerful innovation yet, the Apex 300. In recent years, the reality of climate change has become impossible to ignore. Severe weather events are growing more frequent and more intense. For homeowners, this means that utility power outages are no longer inconveniences. They can last for hours, days, or in extreme cases, even longer. The question is no longer if, but when. You'll need a solution to keep your homes powered and your family safe. You can keep your home powered and your family safe during any weather conditions with Bluetti's most powerful innovation yet, the Apex 300, the world's smartest dual voltage portable home energy solution. It's built to power everything from essential appliances to entire homes, with unmatched scalability, ultra efficiency, and instant backup performance. It has 120 240 volt dual voltage output, expandable up to 58 kilowatt hours at 11.52 kilowatts, real-time weather alerts via Bluetti's app, charges via 30 kilowatt solar or 11.52 kilowatt generators. It can power HVACs, electric vehicles, and heavy-duty loads, and it pays for itself in as little as 2 years. In order to get more information and take advantage of this special offer, simply go to this web address. You can also obtain an exclusive offer or a 10% discount by using this code, APEXAFF10. Ready to go beyond just solving problems? If you've been following my daily post and enjoying the sample problems, you're going to love this. All of these problem sets and more are now available, or soon will be, on my official course site, my stand store for electrical training. Just go to the web address that you see at the bottom of this slide, https://stand.store/GVB.